We'll say that again. So if you want to find an inverse, you switch x and y, and you solve for y. Sorry, I already had done that. Okay, in our case, I want to find the inverse trig function. And I am intentionally, instead of using x here as sign of x, I'm using theta, because I think when you all see theta, you think angle. And I need you to realize we're talking about an angle here. So if I want to switch x and y, okay, I can do that. All right, I can go, hey, dude, let's switch. But, okay, is that kind of make sense?
Don't even know what sign is.
Because, let me give you an example. If I had, say I'd actually had a number in there and I did sine of pi over 6, if I switched it to write it as an inverse, I'd be saying pi over 6 equals the sine of a half. Well, can you have the sine of a half when the half is a number and not an angle? No. So when we switch it, we have to put something on it to say, hey, dude, this is an inverse now. I've switched that sign. How do we write inverse sign? You've been using it on your calculator. Yeah. So we say, oh, anytime when I switch the variables, then you have to tack the little inverse symbol on that trig function. Otherwise, you don't realize it's an inverse. Now, Luke was just asking me, though, looking at this worksheet, why is there arc in front of some of these words? That's because there's two notations for inverse. Some mathematicians don't like little -1 because it looks like a -1 power. And how do you know whether it means a -1 power or it means inverse? So there's a second notation we write them in. We also will write them as arc sign. It means the exact same thing as inverse sign. They're identical. It's just two different notations. Different textbooks use different notations. Your book uses both. It mixes it up. And my worksheet mixes it up on it so that you get used to seeing both. I've had calc books that will go one way and then the next calc book will go the other way. So you have to recognize that on both instances, they both mean inverse. So that's all that is. Okay, the key thing I need you guys to realize is when you solve an inverse trig function, when we did inverse sine of a half here, what was it equal to? Pi over 6, which is a what? An angle. Inverse trig functions represent angles. That's critical. When you see an inverse trig function, your answer will be an angle. Okay, did you not just hit inverse on your calculator several times on that quest?
Yeah.
And every time you were searching for the angles. You don't know what I'm talking about? You didn't hit inverse on that quest?
Not one time.
Well, we showed it.
You had all special angle answers? Okay, oh, God, you're going to worry me. Okay, that's a really ugly color together there, but okay. That's key. Inverse trig functions are angles. Okay, well, here's our wrinkle to this whole situation, and this is where I would normally spend 15, 20 minutes to writing this, but now you all are going to believe me in the next 2 minutes. Okay. Our problem with inverses. You will recognize this is a graph of nice little sine wave here, this first one. Okay, if you graph an inverse trig function, if you switch x and y, what are those waves going to do? Yeah, they go up and down. Whoops. That won't work. But yeah, if you do inverse sine, it still starts at the origin, but it weaves up and down the y-axis. Thank you. Thank you, Luke. That is not a function. Okay? You wouldn't pass the vertical line test. So they said, all right, then we are going to cut it down. And we're going to limit sine to just a certain little area of the graph so we can have an inverse as a function. So they literally went, where can we chop off the graph of sine and make it be a function? And notice, if it's winding up the y-axis as an inverse, then over here on the regular graph, I'm just wanting to make sure it passes the horizontal line test. So these pink lines I drew in here at negative pi over 2 and positive pi over 2, they chop off the graph of sine. Would that pass the horizontal line test? So when you do the inverse, it would pass the vertical line test. Okay. What that's doing, though, is that's limiting your quadrants. But it's kind of weird, because it's limiting you between negative pi over 2 and positive pi over 2. So you got to think about that one a second. Negative pi over 2 would be where?
It would be
Where do you...
down.
Pi over 2 is
Pi,
90.
okay, because that's positive pi over 2 up there. But if you went negative, what's it mean to do negative?
So it'd be down at like the 270
Yeah,
mark.
it's the 270 line. It means go backwards. So since they chopped this thing off going from negative pi over 2 to 0 to positive pi over 2, it's like it's coming through this range of numbers, which limits you to what quadrants?
First and fourth.
First and fourth, yes. So we remember that then inverse sine is only good in the first and fourth quadrants. You can't have inverse sine in the second, third. You're actually going to discover here they each have one quadrant where they're positive and one quadrant where they're negative. We don't get to use all four anymore. Okay, now this is where you all kind of follow the concept. This is where I want to
Wait a minute, it's positive on the graph and negative on the bottom. This by hand.
graph these. No, you're not graphing these at all. You have to know we're about to change All-Star Trig class to another saying.
You're a horrible person.
You'll like this one. It was the same people who created butt crack graphs created this one.
So, we should have gotten rid of them two at the same time.
Alright, so the point is, then they chopped off cosine. Well, if you chop off cosine, so it's going to pass the horizontal line test here. They just chopped it from 0 to pi. They just chopped it in that range. So if you go from 0 around to pi, it puts inverse cosine in the first and second quadrants. Those
Tangent goes into the second and third.
no. Nothing gets to be in the third.
It goes in the...
That's why.
Because I mean, the logical place to cut off this tangent is just one period of tangent, which is from negative pi over 2 to positive pi over 2, which is the same thing as this is here. So tangent is in first and fourth, just like sine. Okay, I got to do this in the right order to get the saying to go. Yeah, okay. I need to move my sign a second. I don't know why we would have had this out of order the year, or maybe they scrambled it to make their same. I don't remember which. Okay, you may be able to tell I'm capitalizing these. Okay, if they're capitalized, it means you're using these limited quadrants. If you see inverse trig functions that aren't capitalized, then you're using all four quadrants. We are always going to be using capitals. We're using these quadrants, okay? But occasionally in some other areas of math, you might not. So can I speed it up now and just tell you what the others are? Okay. Okay, turns out cosine, secant, its buddy, of course, and cotangent land in the second quadrant. And cosecant, sine, and tangent line in the fourth quadrant, and there's absolutely nothing in the third quadrant. Okay. And of course they're all, I should say, they're all over here. Cosecant, secant, and cotangent. Okay, I'm somewhat concerned about saying this on video, but okay. They're sitting there going, okay, notice they're all in the first quadrant, so they call the first quadrant now all. Okay. So it goes Cody, you have to know you have to keep the COs separate of the CSs. Oh, this is this yeah.
Which one was it, Honeyman or Hudson?
Honeyman. Cody sells cocaine.
All
At, they use the A, they use all, at crazy sexy time.
No, do a different one, like.
Oh, there was also, they had something sells corn, co-op sells corn.
crazy sexy time.
I don't remember what the other one was. So, make up your own, I don't care, you gotta keep it straight. So, however, the wilder it is, the better we seem to remember it.
Well, it's only awkward for you. It's not awkward for us.
Yeah, that's kind of what I figure. Okay, so those, I'm going to pause a second. I need to write those out here so you can keep those, because those quadrants are back on here first. Okay. Now, the other interesting thing is, when you go to write answers here in a minute, your answers are going to be angles. Okay, so angles in the first quadrant will be fine, normal in the second. Because we defined this fourth quadrant angles as negative pi over 2, we went backwards. You will write your fourth quadrant answers as negative angles. Instead of saying 11 pi over 6, you're just going to say negative pi over 6. It went backwards pi over 6. You're not going to go all the way around to 11 pi over 6. It actually makes your life easier, other than you have to remember to do it. That's the downside, if you have to remember to do it. So actually working the problems isn't bad at all. All right, so I'm asking you, what's the inverse cosecant of 2? You're going to look at that and go, it's an inverse trig function. My answer is, what kind of an answer? An angle. Okay, these are always in radians, never in degrees. No, you won't need to do your calculators. It's going to be special angles. You do inverse trig functions in radians without fail. So, you're all going to go, oh, it's the same thing you've just been doing. Inverse cosecant is a positive 2. So what quadrant am I in if inverse cosecant is positive? Because realize, they're all positive in the first. They would be, these three down here are negative in the fourth quadrant, these three are negative in the second quadrant. So the only place where they're positive is in the first quadrant. That's the only time. If you have a positive one, it can only be in the first quadrant. Technically, you should be drawing a picture and going, okay, if cosecant equals 2, I mean sine equals what?
1.
A half. So where's sine a half in radians? Pi over 6. Thank you. And since it's a first quadrant angle, your answer is pi over 6.
Why didn't you put that in the one below that?
Okay. Arc cosine means inverse cosine. Same thing.
I'm talking the problem below.
Yeah?
Why didn't that go in the one below?
Because the fourth quadrant, cosecant, sine, they're all negative in the fourth quadrant.
They're all negative.
Yeah. So now this one, you go, oh, this is an inverse cosine that's negative. So therefore, where is inverse cosine negative? It's only in the second. Where's cosine square root of 2 over 2? But we're in radians always.
No, 45 is always pi over 4, and the 4s go together.
Pi over 4, yeah. Okay, the 4s go together. So that's pi over 4. So then you actually have to name what's the angle from 0 over to that. This is pi. Go back a fourth. 3 pi over 4. Same thing you just did. That's 3 pi over 4. And you just have the one answer. All right. Here we go. Its inverse sign is negative. Where is it?
The fourth quadrant?
It's the fourth quadrant. Okay, square root of 3 over 2 is pi over 3. Yeah. Now, do I write it as 5 pi over 3 then?
No, just pi over, negative pi over 3.
Bingo! It is in the fourth quadrant. You're going backwards. It is just negative pi over 3. That's all it is. So you just, if you're in fourth quadrant, because of the way we cut off those graphs, because the way we cut off the graphs, we went backwards to pi over 2. We write fourth quadrant angles as negatives. That's okay. Which is why when you all were doing those inverse trig functions in your calculator, and you were, if you put in the inverse sign of negative 1/2, your calculator spit out at you negative 30 degrees or negative. It's because it knows those quadrants. Your calculator, when you do an inverse trig function on your calculator, you put a negative number in, your calculator gives you an answer in the correct quadrant. It's been programmed to use those. Not quite. Let me get you this one. Okay, this is a negative inverse secant. What quadrant? Second. Okay, that's going to be a pi over 4. It's a square root of 2. Okay, so if it's an answer in the second quadrant, what do I give?
No. Wouldn't you say the same as they are?
then if it's in the second quadrant, it's normal. That's how many fourths? That would be 3 pi over 4. Okay, so when you, on your calculator, when you put in inverse cosine of negative 1/2, your calculator is going to tell you an answer of 120 degrees. Because it's been programmed to get, because it knows inverse cosine or inverse secant belongs, when it's negative, it's in the second quadrant, so it gives you a second quadrant answer. When you plug in a negative inverse sine, your calculator spits out a negative answer because it knows to do it in the fourth quadrant as a negative answer. Your quadrant's been programmed to it knows which quadrant. Inverse sine's negative in the fourth, so that's where it puts it. It's pretty amazing, actually. They built all that in there. All right. I don't know if we need to do other. One last one. Inverse tangent negative 1. Fourth.
45 degrees.
Yeah.
It's negative pi over 4.
And because we're going fourth quadrant, we're going backwards, so that answer is just negative pi over 4.
So anytime it's in the fourth quadrant, it's getting negative.
Anytime it's in the fourth quadrant, it's just a negative angle.
Is this all we have in our test? Question quiz or whatever?
What now? Okay. Yeah, but it's not that it's negative. It's how we defined it when we cut it off. When we cut that sine wave off, they defined it from negative pi over 2 to positive pi over 2. So they're defining this quadrant as angles going backwards. It's not, but when you're over here in this quadrant, it's just like normal. It's only fourth quadrant. You have to put a negative on your angle answer. Everything else you do completely normal.
Is this all it's going to be on our test?
Heck no. Okay, so what if I ask you the cosine of the arctangent is 33? Okay. I'm going to show you could do the special angle value and go, where is this? Or, actually, I'd rather do this one down here, the second one, the sine of the inverse cotangent of negative 12/5. Is 12/5 a special angle value? Nope, it's not. This is the sine of an angle. That inverse trig function is an angle. Okay? What quadrant would this angle be in if it's a negative 12/5? Inverse cotangent is negative in second. Okay? When it's not special angles, you simply draw the picture. Cotangent is x over y. So that would be 12 and 5. Which one gets the negative? 12 gets the negative. You're going to have to do some Pythagorean theorem. This is a perfect triple. This is 13, yes. So you're going to draw the picture. This is the picture of this unknown angle. That inverse trig function is an angle. It's asking you what's the sine of that angle. You don't have to actually know the size of the angle. You just look at the picture. What's sine out of that picture? Sine is y over r, so it is 5 over 13, and that's your answer. So if it asks you for the something of the inverse something, just draw the picture and get the answer out. You don't even have to do special angles.
So that's all that's right?
Well, I got a couple more examples of this going yet.
Are we gonna have like crazy equations with this?
No.
Do we really even need a calculator for this?
Pythagorean theorems would all be all you need a calculator for. Not anything major. Okay, so what if I ask you this so she knows it? What's weird about that one on the top right? Okay, this one's going to bug you a little bit, but I need for calculus. We use this. Okay, do I know what that's x over 4. Do I know what quadrant that's in? Nope. So if you don't know since it's variables, you just throw it in the first quadrant because x could represent anything. So you're going to go, okay, I'm going to draw a picture. And I'm going to do, I want you to find the secant of the inverse cosecant. So I have to go, all right, I'm going to draw a picture. What sides do I know in my triangle? Yeah. Or if it helps you, if you don't like mixing the r's and y's and x's, you can think of it as its hypotenuse over opposite, whichever way you like it. So this actually is going to give you an expression in terms of x's. It's kind of weird, but it's actually kind of cool. So if r is x and y is 4, to do secant of that angle, secant is r over x. Okay, I don't know side x yet. And this is the problem with this. I wish they always use x's, and it confuses you because you have more than one x in a problem. So what do you want to call this side that we don't know? Q?
I love Q.
No.
A, I like A. Okay, it's A.
That looks like a Q anyway.
So would you agree that that's a squared plus 16 equals x squared?
Yeah.
You are solving for A. How do you solve for A? You subtract the 16. 16. Okay, and then I'm going to square root it. Am I allowed to break that square root down? No, you cannot. You can't. Not when there's subtraction there. That stays square root of x squared minus 16. No, you could, but it won't help you any. You're just going to leave it that way. So this side is now the square root of x squared minus 16. Answer the question. It wanted to know what's secant of that angle.
R would be X
So
over.
side R, which is x, over side x. This is the annoying part.
Square root of X squared minus 16.
Yeah, and we won't rationalize it when it's got an expression like that in it. We leave it that way. That's our answer right there. That's what we want. X over square root of x minus 16. Calculus is about to put this to use in a few weeks. In the middle of this giant calc problem, they're going to have to do that.
So they won't really care about that so much.
Yeah, they're about to bring back all the trig they ever knew. I know, but I'm about to run out of. I probably should.